Hey, glad to see you back. Welcome out to another edition of Trek 9000, where our mission, since we've decided to accept it, was to boldly code where few Pythoneers code before. Yeah, very, very punny, but let's get on with it. In this update, what I'm going to be doing is going through a Wagile update that I'm calling Hack-a-Trek, or Hack-a-Game Trek, for lack of a better. And from last episode, if you had a chance to tune in, you remember that we simply went over the code up on GitHub. We took a look at the Enterprise, the Klingon display types, as well as the abstractions they all inherit from, as well as showed you how to run not only the console TUI, but also, hopefully you noticed there was a test case in our con class that allowed us to complete our mission. Reviewing the code we saw in the last video, you may remember that we had something called ABS ship, and ABS ship had simply a abstract method, which I personally like to use the A notation here. And of course, colors are simply optional, certainly not part of the standard, but it helps us understand and detect on the chart that we have an abstract class, and also using the curly braces, or squirrely braces I like to call them, is also not part of the standard, but we still get the idea there's something different going on with that class. And what is different, of course, is that we are unable to instance or create ABS ship directly without having something providing that abstract method. Also, in the last video, we talked about how both Klingon as well as Enterprise have their own glyph, or git glyph, that will create a glyph. We haven't really defined what that is. We don't need to at this point in time, because whatever framework we're going to be using, that glyph may indeed be different. So all we have to do is have an opportunity, for example, for a Klingon, we might even call it a TUI Klingon or a TUI Enterprise, to get a glyph, because what we're returning is that wonderful little display that we see whenever we show our ships on the screen in our sector view. Now, traditionally, of course, whenever we create a abstract ship, we like to put, for example, 2 greater than and 2 less than signs over top of the definition. That's commonly called a stereotype, and there are so many different stereotypes, I suppose we shouldn't talk about them in any great detail, but just note that we have an abstract or an interface or a timer or any type of abstraction we want that tells us that we have something stereotypical going on with the class. In this case, it's a stereotyped abstract class, which is going to have some concrete implementations before we can do anything useful with that signature, in this case, the get underscored glyph member function. So in addition to having a plus sign saying that get glyph is going to be public once we implement that abstraction, we also have the idea of doing things that are protected, or things that should only be available to the type of Klingon classes, or friend operations that might be only useful for friends or allies to reuse. We also, of course, would have private ship options. And where we have a private member function, on UML at least, rather than using a double underscore like we would in Python, we use a tilde, as we see here. So once again, in Python, we might have a single underscore rather than a pound sign. Public might have nothing, because everything defaults to public by definition, but you get the idea. In as much as we have many different notations, I feel it no crime to come up with our own, just to make things interesting. And from colorization to using A, like we see here, not part of the standard, it's more important that we get things done so people understand what we're doing than it is to strictly stick with the best practices. So the best practices, of course, are simply as we see here, to have a concrete class with no stereotype over top of it. We have a plus for public, pound for protected, tilde for private, as well as stereotypes, which can allow us to do anything we want. And I personally like to add a little color to certainly add some pizzazz, and I've even used Unicode in the past to simply make things fun for people and allow people to quickly summarize what's going on the screen. For example, putting a smiley face or a frowny face or green, red, yellow colors, depending upon what those mean in the culture or company, to make my documentation a lot more scannable and easily reviewable for people in my problem domain. So our last mission, of course, was simply to go to GitHub, download the code, and then hack the display. Let's take a moment to review what we have for the ABS display. Once again, I deliberately misnamed that to a classical class name that we might see in Python. For people who have other reasons than using the PEP in their legacy code, and it's no crime, as we'll be discussing later on as we review PEP 8. But here we're simply going to say, using my notation, which I think is the best practice, to say that this is abstract, and rather than having people figure it out for themselves by looking at a stereotype, I'll simply use a new notation, which I haven't found very handy anywhere else. Now, if we wanted to do something purely Pythonic, of course, we could use underscores, single, double, or none. But you get the idea. There's no holds bar. UML isn't prescriptive any more than PEP 8 is supposed to be. And so let's take a look at our solution to the hackathon activity from the last video.